So I'm starting with today's discussion. So this was the overall view of what we have covered. I will simply recapitulate in 1 minute because many of you were not present the other day. So this is the Navier-Stokes equation for an incompressible region of flow, and this is the continuity equation for incompressible region of flow. So this Navier-Stokes equation could actually be thought of as the generalization in which if we put certain terms equal to 0, we end up in these special cases. So I have laid down here that if certain terms are 0, for instance, particularly the simplest one is if it is steady state, if there is no convective acceleration, there is no viscous effects, then you are left with only this term and this term. And you know that these two terms, this represents what? The equation of hydrostatics. This is the equation of hydrostatics, like this. I think you are conversant with this. So Navier-Stokes equation actually is the parent equation from which you can derive all other equations that you have studied or you will study. And this is called the cornerstone of fluid mechanics because this equation actually is the parent equation for all other simplifications. So if you know this equation, you simply know the entire fluid mechanics. So now we are neglecting certain terms you are seeing here. We are putting certain terms equal to 0. So what should be the basis of putting certain terms equal to 0? Or putting certain terms less than certain other terms? So how will you actually quantify that which term should be 0 in a given situation? For instance, if there is a pipe flow in X direction, what do you think? What should be the V component and W component velocities? When pipe flow is there, flow is in say X direction, you have only U as non-zero component. Do you think you have V and W components of velocity here or not in case of laminar flow? Ayush?
Yes,
Ayush?
sir. Yes, sir.
What do you think? There should be certain value of V or W, it should be equal to 0.
Sir, it should be equal to 0.
It should be equal to 0. And what about whether U changes along the radial direction? So curly U by curly R should be 0 or non-zero?
Non-zero.
Non-zero. Curly U by curly X should be 0 or non-zero in fully developed flow?
Non-zero.
Curly U by curly X.
सर x के साथ चेंज तो हो रही है ना स्पीड नहीं कांस्टेंट है नहीं नहीं नहीं
कांस्टेंट है
सर
अगर आपके पास
यस सर कांस्टेंट है
the entry region.
Sir, constant is 0.
So you have the same parabolic profile. It is independent of X.
यस
So these are the simplifications you make to the generalized Navier-Stokes equation, and you end up in whole lot of equations that themselves form various chapters. But you need not bother because putting these equal to 0, certain terms equal to 0, you end up in those equations. So if you remember this equation, you can simply derive these equations by simply neglecting certain terms, nothing more than that. Now, which term is to be neglected? It could be actually identified simply by common sense in certain simple cases, like you could identify in a pipe flow. But in many instances, that common sense does not work. So you need to devise a method which you will follow to find out which terms could you neglect. And that analysis is called the scaling analysis. Scaling analysis. That is, you find out the magnitudes of each of those terms and then try to see which magnitude is low so that you can neglect that term. So that kind of quantification is called scaling analysis. And the first step in scaling analysis is you non-dimensionalize the equation. So what do you mean by non-dimensionalizing an equation? What do you mean by non-dimensionalizing an equation? Say I have x square plus
constant से sir replace.
constant से replace कर देना. So this say what are the units of x square and y square? So this is length. So units are L2. Dimensions are L2.
Yes sir.
Now if you want to non-dimensionalize this, what should you divide with this? Certain, say constant. Now what are the units of this?
Zero.
What are the dimensions
L0.
of this rather? It is dimensionless.
Yes sir.
So this is called non-dimensionalizing an equation. So first step in scaling analysis is non-dimensionalizing the given equation. So this is, I have laid down here certain fundamental concepts so that you don't confuse when you try to non-dimensionalize. So what are the dimensions of derivative, first order derivative? What do you think? I've already written down here. What are the dimensions? Is this dimensionless or it has some dimensions? What are the dimensions of first derivative?
Dimensionless, sir.
This is dimensionless. What about second derivative? Second derivative is actually
Time.
rate of change of first derivative.
Inverse.
Inverse of length.
So this is inverse of length. And this is a generalized formula so that you don't confuse in your numericals. So you know that if it is dny by dxn, the dimensions will be L 1 minus n or n minus 1.
One minus n.
1 minus n. So this should be remembered. Likewise for integration, if you have y dx, the dimensions will be square.
Where?
You have a double integral. Then what?
Cube.
Double integral. So a is what? If a is a constant,
Square.
then square. If a is not a constant, it is not a dimensionless constant, then it is cube. And any doubts to anyone? And non-dimensionalization actually leads to certain non-dimensional numbers also. Have you heard about any non-dimensional number? What about Reynolds number?
RE.
Reynolds number is what?
Dimensionless.
Dimensionless. It is rho Vd upon mu. And if you try to find out the dimensions of this, it will be dimensionless.
Yes.
So what is the benefit of Reynolds number?
So used for both flows, sir.
What is the benefit? For instance, you were to carry out an experiment and there was a say pipe, and I ask you, you need to find, let me know whether the pressure drop in this pipe will scale with, how will it change with diameter of the pipe, how will it change with the density of the fluid that is flowing, how it will change with the viscosity of the fluid, it will change. So if you want to study the effect of each and every parameter, then it would be very difficult for you to carry out the experiments, because the number of experiments will be very large.
ये D Z1 Z2 क्या सर?
कौन से वाला, ये वाला?
Yes sir.
ये तो इस तरह से मान लो ऐसे होता, डबल इंटीग्रल dx dy, तो क्या होता है इसके यूनिट्स? एक्स वाई एल स्क्वायर. Are you clear? है? dz1 dz2 are two variables, so this is a generalized integral. Instead of dx dy, it is written down as dz1 dz2, nothing more than that. And clear? है?
Yes sir.
Now, to demonstrate this point, so this is a propeller, and you are asked to find out the thrust force F of a propeller. So what all parameters will it depend on? What do you think? What all parameters will depend? Its power will depend on what all parameters?
So the input current, the aerodynamic viscosity, जिस भी fluid में उड़ेगा, and the fan blade length, fan blade size, mass.
So there are many number of variables that will actually alter this thrust force. So how will you identify those parameters? First of all,
एक्सपेरिमेंट से सर अलग अलग चीज वेरी करके.
experiment say you will carry out preliminary experiments, but if I ask you how it will vary, what will be your answer? That is, they say thrust force, whether it is directly proportional to D or it is directly proportional to D square or 1 by D cube. How will you find it out?
Graph plotting.
हाँ जी,
Graph plotting sir, initial और final values के बीच में graph plot कर
लेकिन
लेंगे
it is
उससे.
not possible that you vary each and every parameter like this.
सर ऐसे तो बहुत सारे केसेस बन जाएंगे उसमें.
बहुत सारे केसेस बन जाएंगे. So that's why now comes the role of dimensional analysis. That is to reduce the number of variables, like in Reynolds number also, rho Vd upon mu. When Reynolds number is say 2000,
अच्छा सर ऐसे कर देंगे कि जो थ्रस्ट है उसको एक कांस्टेंट के फॉर्म में मतलब कर देंगे कि इसके प्रोपोर्शनल है, इस कांस्टेंट के प्रोपोर्शनल है.
okay, but let me know, say Reynolds number is 2000, this 2000 value you could get by number of permutation combinations of these.
यस सर.
Say you were actually making water flow in this pipe with some velocity v1, vw say, so you know that rho w, vw, the diameter was w and mu was mu w. So you got some value of 2000. Somebody else say was carrying out experiments with some oil, so rho o, vo, do, and this was different diameter pipe, velocity was different, density was different, but and viscosity was also different, but it also came out to be 2000. So will you get similar kind of flow behavior and pressure drop in both the cases, or you will get different? Hanji, if this is a pipe, in one case water was flowing, in other case some oil was flowing, and you want to find out what is the pressure drop in the pipes as the fluid is moving, and you were given that you have different fluid properties here, different diameter here, likewise you have different fluid properties and diameter here, but eventually And incidentally, what happened? Reynolds number was same in both the cases. And say surface roughness was also same. Or say E by D was same. Will you get the same pressure drop or not? Hanji. Are you following my point, what I am saying? Aditya? Rajansh?
Yes, sir.
Are you following what I am saying?
Yes, sir.
So what do you think? If Reynolds number is same, will the pressure drop also be same? Or can you say the both will be in laminar regime under normal circumstances?
No sir.
Why?
सब प्रॉपर्टीज ही अलग हैं दोनों की.
But that is what I am saying now. These non-dimensionalized number actually help us in drawing the similarity. Similarity means, for instance, you have heard about the terms called model and prototype.
Yes sir.
So if you are to build an aeroplane, will you build the entire?
नहीं सर, उसका छोटा सा एक मॉडल बनाते हैं.
You will get a small model, and what will you do with this model? If you want
अलग-अलग उसी पे एक्सपेरिमेंट करेंगे सर.
characteristics.
सर जो प्रोटोटाइप है उसका सिमिलर मॉडल बनाएंगे, छोटा सा वर्जन.
छोटा सा मॉडल बनाओगे आप उसका, and then you will actually make the fluid flow past that model, and you will look at how does it behave, and these results could actually then be extrapolated to the real life prototype. So was the density same here? Say, I give you an example. All of you understand what is a submarine?
Yeah.
So submarine is immersed in which fluid? It is immersed in water. So submarine works in water, but for testing purposes, say you make a model of submarine and put it in a wind tunnel. Wind tunnel is actually a kind of conduit in which wind is blown over that body to simulate the real life situation. It is somewhat like this. Somewhat like this. This one. So this is a submarine, and you are making the air flow past this submarine. Although this submarine is not of same size, neither it is in the same fluid, but the results you get from here can actually be applied to the real submarine. So it is at this stage when these non-dimensional numbers like Reynolds number play a critical role. So what you do is you try to actually keep the same Reynolds number here as it will be in real situation. Because you know that rho, V, D and mu are different, because mu here is air. Velocity, you can actually say same velocity or some multiple of that. Rho is different of air. This dimension is also different because this is not the actual submarine. This must be some scaled value of D. But what is same is like this. RE model is equal to RE prototype. So this is what you tend to make in case of testing of the model. Not the individual.
RE model equals to RE prototype कैसे हुआ?
RE model. So say I ask you a simple question. What do you expect the model should be in terms of prototype? अगर prototype ये है तो model में आप क्या चाहोगे? Shape should be same. First thing.
Yes sir.
Shape should be same. What else should be same? size can be same or not?
नो सर,
शेप
साइज बड़ा होगा।
साइज बड़ा होगा सर।
Shape I am saying
शेप
shape will be
शेप
same.
सेम रहेगी,
Shape
साइज
same
बड़ा
रहेगी.
होगा।
Size can be scaled up or scaled
डाउन, यस सर।
down. Clear है? What about the velocities? Velocity should be same or different?
अलग अलग होंगे सर।
Velocities will be different, but they should be multiple of each other
यस सर।
into some multiplying factor, say mf. What about forces?
सर वो भी प्रोपोर्शनली होंगे सर।
Forces भी proportional होंगी. So please remember, when you try to maintain the shape, this is called geometric similarity. When you try to maintain the kinematics, like velocity, acceleration, all that stuff, it is called kinematic similarity. And when you
ये जो
try to,
एमएफ से जो एमएफ लिया हुआ है वो वेलोसिटी स्केल रेशियो है क्या?
हाँ, मतलब बेसिकली v मॉडल अपॉन v प्रोटोटाइप एक फैक्टर आएगा, वो लेस देन 1 भी हो सकता है, ग्रेटर देन 1 भी हो सकता है, इक्वल टू 1 भी हो सकता है. So this and fourth thing is called dynamic similarity. So what we do is, when all these similarities are met, then we say that model analysis is similar to that of prototype. So for complete similarity, we require kinematic, geometric, and dynamic similarities. So I'm giving you 30 seconds. You can read from here as well. Of same shape, may be scaled by some constant scalar factor. Then kinematic similarity, then that is velocity or something like that. Those should be equal. Then dynamic similarity, all forces in the model should be scaled constant of that in the prototype. So complete similarity between model and prototype is achieved only when there is geometric.
सर इसमें क्या क्या कर रहे हैं हम सिमिलर मतलब?
देखो, आप मेरे को बताओ, अगर आपको एरोप्लेन को बनाना है, जैसे आपको पता है बोइंग कंपनी है, एयरबस कंपनी है, जब इन्होंने एरोप्लेन बनाना है, क्या ये उसमें और वो फाइनल डिजाइन नहीं है, तो क्या ये अफोर्ड कर सकते हैं कि बार बार बनाएं, उस पर चेक करें?
महंगा पड़ेगा,
बहुत महंगा पड़ेगा. तो वो क्या करते हैं कि उसका छोटा सा मॉडल बना देते हैं. अब उस छोटे से मॉडल को वो टेस्ट करते हैं एक विंड टनल में. विंड टनल में मतलब क्या है, इस पे ड्रैग फोर्सेस लगेंगी, क्या है, इस पे लिफ्ट होगी, कैसे ये बिहेव करेगा स्ट्रक्चरली, तो सब कुछ इसको यहां पे रख के यहां से विंड ब्लो करनी स्टार्ट कर देते हैं. तो ये विंड ब्लो करना इस स्टेशनरी एरोप्लेन पे सेम है जब एरोप्लेन हवा में खुद ट्रेवल कर रहा है, बिकॉज यहां भी रिलेटिव मोशन है, यहां भी रिलेटिव मोशन है. तो आप दोनों चीजों को सिमिलरली सिमुलेट कर रहे हो. आप समझ रहे हो? लैब में तो ये पॉसिबल नहीं है कि आप एरोप्लेन को उतनी स्पीड से घुमाओ और उस पर चेक करो. तो उससे अच्छा क्या है कि एरोप्लेन को स्टिल रखो, उस पर एयर को ब्लो करवा दो. तो आपने जो छोटा सा मॉडल लिया, उस पे जो रिजल्ट्स आ रहे हैं, मान लो ड्रैग फोर्स आ रही है या कुछ भी आ रहा है, तो क्या वो आप उसको एक्सट्रापोलेट करके बड़े एरोप्लेन पे लगा सकते हो कि नहीं लगा सकते हो? वो तब लगा सकते हो सिर्फ अगर ये तीनों तरह की सिमिलैरिटीज आपने मेंटेन करी हैं जब आप एक्सपेरिमेंट कर रहे थे. मान लो आपका एरोप्लेन की शेप कुछ और थी, आपने मॉडल कुछ और तरह का बना दिया, तो इसके रिजल्ट्स इस पे एक्सट्रापोलेट तो नहीं हो सकते. हाँ जी, क्लियर है? हाँ जी, क्लियर है आयुष?
यस सर.
So to actually carry out experiments on a model, the model should be similar in all respects to the prototype. Prototype का मतलब है जो actual plane बनेगा या ship बनेगी या जो भी बनेगा. So that is, there should be three similarities: geometric similarity, kinematic similarity and dynamic similarity.
मतलब सर जितनी भी सिमिलरिटी देख रहे हैं वो मॉडल और प्रोटोटाइप के बीच में देख रहे हैं ना.
हाँ, तो ज्योमेट्रिक सिमिलरिटी का मतलब क्या हो, दोनों की शेप सेम है. क्लियर है?
ठीक है.
अब जैसे एक और एग्जांपल यहां पे गिवन है, मान लीजिए कोई फ्लड आ रहा है, जैसे ये फ्लड है, मान लीजिए ये कोई रिवर है. आपको पता लगाना है कि इसके आसपास वाली ये जो जगहें हैं इन पे क्या नुकसान हो सकता है. ठीक है, आप रिवर पे जाके एक्सपेरिमेंट तो नहीं कर सकते कि रिवर का फ्लो रेट बढ़ा दो, रिवर का फ्लो रेट कम कर दो, ऐसे काम तो नहीं कर सकते आप. तो आप क्या कर सकते हो, आप देखोगे यहां पे फ्लो रेट इंक्रीज या डिक्रीज करके इसके सराउंडिंग रीजन को क्या फर्क पड़ता है. तो इसके लिए आपको क्या करना पड़ेगा, इसका एक्चुअली टेरेन रिवर की तरह होना चाहिए जिसको आप सिमुलेट कर रहे हो. इसके आसपास की जो जगह है वो भी सिमिलर होनी चाहिए जो आप एक्चुअल में जहां पे रिवर फ्लो कर रही है. तो कुछ प्रॉपर्टीज आप उसकी देख लोगे जो सिमिलर होनी चाहिए. तो जो इस पे रिजल्ट्स आएंगे तो आप एक्चुअली प्रिडिक्ट कर पाओगे कि यहां पे आपने मान लो एक्चुअल नदी में कोई फ्लो मीटर लगा रखा है कहीं पे, तो आपको पता है कि यहां पे अगर ये फ्लो रेट मीटर क्यू सी से अगर एक्सीड कर गया तो यहां पे फ्लड हो सकता है. तो आप एक्चुअल रिवर में वो क्यूसी की वैल्यू को मॉनिटर करते रहोगे कि अगर वो क्यूसी से ज्यादा आ गया, यू नो दैट आपने एक्सपेरिमेंट जब किए थे तो फ्लड आ गया था यहां पे और इतना इरोड कर दिया था, तो आप वहां पे इवैक्यूएट करवा लोगे लोगों को कि जो भी पास में रह रहे हैं रिवर के. सो दिस इज
Sir,
हाउ यू एक्चुअली मॉडल द रियल सिचुएशन.
sir, I wanted to ask one thing.
हाँ जी,
सर जैसा अभी आपने बोला कि जो मॉडल है वो स्केल डाउन होता है ताकि हम उस पे अपनी सिमुलेशंस कर पाएं,
देखिए
राइट?
स्केल अप भी हो सकता है.
हाँ जी, मतलब स्केल अप या स्केल डाउन जैसे भी हो सकता है.
ठीक है.
एंड सिमिलरली सर जो फोर्सेस हम उसकी स्टडी के टाइम पे लगाएंगे
हाँ
वो जो एक्चुअल मॉडल या एक्चुअल प्रोडक्ट पे लगेगी उसका कुछ फैक्टर होगा, लाइक उसका कुछ मल्टीपल होगा.
हाँ हाँ.
तो सर इस प्रोसेस से मतलब हम मतलब सारी इम्पोर्टेंस तो फिर उस फैक्टर की होगी ना काफ़ी ज़्यादा. तो हम इस मेथड से सर वो फैक्टर भी डिटरमाइन करते हैं या वो अलग प्रोसेस होता है, हम
वो
सिर्फ यहाँ
अलग
पे?
प्रोसेस है. इसमें हम सिंपल क्या करते हैं, फैक्टर तो है ही है. जैसे पर्टिकुलरली मान लीजिए फॉर इंस्टेंस, इसमें एक चीज और भी ध्यान रखनी पड़ती है आपको. मान लीजिए से यू आर डिजाइनिंग अ माइक्रो चैनल. माइक्रो चैनल आप समझते हैं कि जो चैनल का विड्थ या डायमेंशन है वो माइक्रोन्स में है. ठीक है, से अगर आप इसका स्केल्ड अप वर्जन बना दोगे, प्रॉब्लम क्या आएगी. मान लो कोई माइक्रो चैनल था, एक सिलिंड्रिकल माइक्रो चैनल जिसका डायमीटर मान लीजिए 2 माइक्रोन था. अब आप में से किसी ने उसको स्केल अप करके यहाँ पे एक पाइप बना ली, उसका डायमीटर मान लीजिए 2 सेंटीमीटर.
कैरेक्टरिस्टिक लेंथ ही बदल जाएगा सर.
हाँ, तो इसमें क्या प्रॉब्लम क्या आएगी दोनों केसेस में अगर आप इसको ऐसे स्केल अप करते हो.
सर वो जो सरफेस से एडहेशन आता है उसकी वजह से प्रॉपर्टीज में फर्क आ
हाँ, तो
सकता
जो
है ना
फिजिक्स है,
maintenance में.
फिजिक्स है वही कैप्चर प्रॉपरली नहीं हो रही.
यस सर.
इसमें सरफेस टेंशन इफेक्ट्स बहुत ज्यादा होंगे,
यस सर.
इसमें नहीं होंगे. तो जो आपके इसके रिजल्ट्स हैं, यू कैन नॉट एक्सट्रापोलेट टू दिस.
यस सर.
So in terms of geometric, then kinematic and then dynamic similarity, you should also maintain the fact that exact or accurate physics is captured. If physics is all not captured, there is no need or no worth of this analysis. And that factor you were pointing out, that also actually involves lot of experience and lot of study after you have identified certain non-dimensional numbers, that which factor is correct and which factor is incorrect.
एग्जैक्टली सर, क्योंकि सारी चीज तो फिर उसी एक फैक्टर पे आ जाएगी।
हाँ, क्योंकि अगर मान लीजिए कोई बहुत ही छोटा बना रहा है और एक बहुत ही बड़ा बना रहा है, उसमें शायद फिजिक्स ही चेंज हो जाए, जैसे मैं आपको बोल रहा हूं. So there must be an appropriate scale up of this or scale down of big thing so that certain physics concepts are not lost. आप समझ रहे हैं? कहीं मान लीजिए प्रोसेसेस बड़े चीज पे ही दिखते हैं, वो छोटे पे नहीं दिखते. तो अगर आप उसको स्केल डाउन कर रहे हैं, आपने स्केल डाउन इतना ज्यादा कर दिया, वो इफेक्ट्स ही खत्म हो गए, then there is no purpose of that similarity. हाँ जी, क्लियर है?
यस सर।
So now I'm coming to, so we have identified that first thing, if we want to actually neglect certain terms in the Navier-Stokes equation, we want to do scaling analysis, and scaling analysis involves neglecting certain terms. And in neglecting certain terms, we need to first non-dimensionalize the equation. And non-dimensionalization of the equation actually leads to certain non-dimensional numbers. And these numbers are important because they help us to build these similarity concepts so that you can actually compare Reynolds number only instead of comparing rho, v, d, mu and each and every variable separately. So you are reducing the number of variables you are studying. So that is the utility of non-dimensionalized numbers. Now we are coming to a concept in which we will be looking at that how to find out those non-dimensionalized numbers. So in this example, something is given to you, that is a propeller thrust is given to you as a function of diameter of this hub, velocity, then RPM of these blades, then density of the fluid and viscosity of the fluid. So these variables you have identified actually through preliminary experiments, but you have not carried out extensive experiments. You still don't know how F is related to each of these variables. You only know that these are the variables which can actually impact the thrust force. That is what you know, nothing more than that. So to build up the relationships and to build up the non-dimensional numbers, what you do is you carry out the dimensional analysis. So dimensional analysis means you will actually make sure that this is a dimensionally homogeneous equation. So what do you mean by dimensionally homogeneous equation? Say if I have, let me know, if you have, say, length is 2 meters, area is 4 meters square. Can you add like this? Can you add like this?
नो सर।
No. So when you are adding things, what do you ensure? That each term has the same dimensions. So this is called maintaining dimensional homogeneity. So in this case also, you try to see what are the dimensions of force in terms of mass, length, time. What are the dimensions of force in terms of mass, length, time? M raised to power 1, L raised to power 1,
-2.
-2. So these are the dimensions of force in terms of mass, length and time. So what you do is you write down the dimensions of each one of these variables, including the dependent variable. So these are the dimensions in terms of the primary dimensions, that is mass, length and time.
सर डिपेंडेंट वेरिएबल क्या?
फोर्स डिपेंडेंट वेरिएबल है ना. आपने थ्रस्ट फोर्स ही तो निकालनी है. वो किसका
Yes,
फंक्शन
sir.
है? डी वी एन रो म्यू. You want to find out how thrust force is dependent on each one of these. So what I am doing is I have laid down all the variables in a single row, and I am laying down these dimensions below each of these variables. हाँ जी, clear है? So now what do you know? Force dimensions you know already. So the combination of all these should have mass dimension of what? In case of force, the dimension of mass is, the exponent of mass is 1. So what does that tell you? What should be also equal to 1 here? What should be equal to 1 here? हाँ जी. Say F.
Rho and mu.
So what should I write down? What should be equal to 1? 1 should be equal to what?
Rho and F. Rho and mu.
Q plus S. And is it clear? रो
Yes,
और
sir.
म्यू के एक्सपोनेंट क्या है?
Yes, sir.
Q और S.
अच्छा हाँ यस सर.
तो ये Q और S के बराबर होना चाहिए मास के केस में. अगर आपने फोर्स को बैलेंस करना है, आप बेसिकली क्या कर रहे हो? फोर्स को क्या लिख रहे हो? कांस्टेंट टाइम्स से d की पावर m, v की पावर p, n की पावर r, p की पावर q, म्यू की पावर s. आपको ये पता नहीं एक्सपोनेंट्स कि कैसे हैं, लेकिन आपको क्या पता है कि इसके जो डायमेंशंस है मास के, वो इन सबके अगर सम कर दूं मैं, जहां जहां पे मास अपीयर हो रहा है वो सेम होने चाहिए. हाँ जी, क्लियर है?
यस सर.
व्हाट अबाउट लेंथ? व्हाट अबाउट लेंथ?
Yes.
फोर्स के क्या है?
P,
1. बाकियों में किस किस के हैं? एक तो d के हैं, इसका मतलब यहाँ पे m आ गया,
M.
और यहाँ
M
पे
P
m
plus P सर.
p
minus 3Q और minus
माइनस
S.
माइनस
3Q
q
Q.
minus S.
माइनस s. हाँ जी, क्लियर है?
यस सर.
व्हाट अबाउट t? व्हाट अबाउट t?
-2 आना चाहिए
-2 should be equal to
सर. minus P
minus p
minus R minus
minus
S.
r and minus s. हाँ जी, क्लियर है? एनी डाउट्स? किसी को कोई भी डाउट?
No sir.
So what is the problem in this equation? How many variables do you have and how many equations do you have? How many
Variables 5 हैं सर और
हाँ जी,
3 equation है. Variables सर 5 हैं.
5 variables and 3
Equations.
equations. So what you will have to do? You will have to write down certain variables in terms of some other known variables.
Yes sir.
So what you do is, we have already done this. So what we have done is, we are writing down certain variables in terms of the other variables. See, I'm writing down Q, P, M in terms of R and S, so that I can substitute the value of Q is equal to 1 minus S and P as this and M as this. So that I have only 2 variables. So this is what I have done here. Is that clear? Now, what do you know? You can take out what is known to you. You don't know R, you don't know S. But you know that this is known 1 value, this is known 2 value, this is known 2 value. So you have taken out all other terms here. And this is like this. And clear hai? And since this equation is valid for any value of S and R, what does that tell you? Because this equation is valid for any S and R. What does that tell you? What should be these terms? These should be dimensionless or have some dimensions.
So dimensionless.
Dimensionless, because R and S are arbitrary. So if this equation is valid for all the cases, it means these terms should be dimensionless. So you have written down force as this constant times the function of these two. So these are the non-dimensional numbers that are relevant in this problem. So instead of looking at rho, v, d, mu independently or n independently, you will look at only these two non-dimensional numbers when you are carrying out similarity analysis. So this has actually reduced the number of variables involved in your similarity analysis. Because in each problem, you will have a different characteristic non-dimensional number, and you need to identify that non-dimensional number. And is that clear? Any doubts? Now I'm coming to the second part. This method of finding out non-dimensional numbers is called indicial method. But this method has one shortcoming. What was the shortcoming? We were getting lesser number of equations as compared to number of variables. So we had to make certain kind of manipulations here. But there is another method to do the same stuff, and that is called the group method or Buckingham pi theorem. Buckingham pi theorem. This is called Buckingham pi theorem, or also called group method. So this method tells you a priori. A priori means without going into details of the analysis, it will simply tell you what are the number of non-dimensional groups that you will get in this problem. So the statement is the number of dimensionless groups arising from a particular matrix formed from n variables in m dimensions is n minus r. R is the largest non-zero determinant that can be formed from the matrix. So what does that tell you? I'm coming to a problem here. So this was a problem in which, say, force was actually dependent on all these parameters. So what you do, as you did in the indicial method, you write down each one of the variables in this first row and the primary dimensions in this first column, and you make this matrix what you are seeing. So what you will see is, as per the statement, what is the number of groups arising from this? Largest non-zero determinant. So how will you find out the largest non-zero determinant in this case? Largest non-zero determinant. इसमें largest non-zero determinant कितना हो सकता है as such? What do you think? In this matrix, what can be size of the determinants? It can be 2 by 2. It can be 3 by 3. Anything else? So what do you think is the largest non-zero determinant in this? So you can pick up any 3 and find out the value of determinant. If it is coming out to be non-zero, then you know that 3 is the order of the determinant. And then these are the variables 1, 2, 3, 4, 5, 6. So you get 6 minus 3 is equal to 3. This is the number of non-dimensional groups that you will get. Because in the indicial method, you didn't know how many groups you will land up in. For instance, in this, you landed in 2 groups, but those were not clear to you initially. But using this Buckingham theorem, you can always find out what is the minimum number of, or what is the number of non-dimensional group that you will find. So the analysis is similar to what is indicial method. So please remember, I'm quickly going through it because this I need to complete it today itself. So what you do is, out of the variables, you choose repeating variables. Repeating variables means you choose n minus r, that is r was 3, this was r was 3. So you choose r number of repeating variables. Repeating variable means the variables which are having all the dimensions. Out of these 6, you choose 3 repeating variables in this case, depending on what is r. So we have chosen VL row as the repeating variable. And we divide each of the other variable with the indices added on these variables. So what do you know? We have 3 groups. So these are the 3 groups which will be formed. And how will you find out this? How can you find out this? How can you find out this? What are the dimensions of force? MLT. These are the dimensions. So you get actually 3 equations from these 3 terms. You have 3 equations, 3 variables. You get the value of A, B, C, and you substitute here, and you finally get 3 non-dimensional numbers. So I think I am running out of time. So I will break for today and we will meet in the next class. So this is all about Buckingham theorem, and these are the 3 non-dimensional numbers. Okay then.